Alright, so I'm going to use a linked list strategy to implement our queue. So first thing first, we need to have our nodes. So public class node e, or sorry, not public class, but private static class node e next, which is going to be a bit tricky here. Because the next thing in the line, right, is the guy behind me, which may make you think it's the previous, but I guess don't think too hard about that one. Just remember, just use the grammatically correct statement, right? The person behind me is the next person in line, which is why we've got a next here, even though the arrows might be drawn the other way. Okay, so and then we've got a e item. Okay, so then I'm going to have four methods like we did before, but first, right, our variables. Node e, and I'm going to, instead of using top or head or tail, I'm going to use front, and node e back, because those make sense for a queue, right? The front of the queue and the back of the queue, the front of the line, the back of the line. Private node front, private node back. Okay, and then let's get our four methods out. Public boolean empty, and I like to call that is empty. So is our queue empty? Return false. Public e peak, which will return the first thing. Return null. Public e poll, which will get the first thing, which will remove the front of the queue. That processes the first item in the queue. Return null. I sometimes like to call it dequeue because it removes somebody from the queue, and I sometimes like to call the offer, which is to back. I like to sometimes call that the enqueue operation. Public boolean. For some reason they do boolean here. Public boolean offer e item. And the reason is because with queues, right, sometimes the line is full and you can't get in the line. So let's go ahead and go through these now. So unfortunately for me, this is going to be slightly more complicated than writing a normal than writing the stack, because I am keeping track of the front and back, which means it's the same as keeping track of the head and tail, which means I do have that edge case within it where if I'm adding to an empty list or something. So first, is it empty? How would I tell if it's empty? Same way with the other one. If front equals null, then it's empty. All right, peak, that's an easy one as well. Return front dot item. All right, poll. Let's go ahead and let's deal with the add method first, and then we'll deal with the remove. Right. So we're always going to be able to return true for this, because with the way we've got this set up, there's always space in our line. It's a linked list. So if is empty. So if this line is empty, then then we're in that edge case where the front and the back are going to be the same item. So if this is empty, let's see, so first node e temp is equal to, or yeah, we'll go ahead and say temp is equal to new node item. And I forgot to make my constructor once again. Give me 1 second. Let's see, does this work? Nope. Alt insert constructor for the node. Nice. Okay, that worked. So we've got a temporary node. if the item is empty, then temp is equal to front. Front is now the, so that temp is now the front, and it also happens to be the back. Nothing, right? It's if you're the only person in the line, you're both the front and the back of the line. Otherwise, we need to attach you to the back. Temp.next, or rather, back.next is equal to temp, right? And this is where where it sometimes gets a bit weird. So I'm gonna go ahead and draw this. LibreOffice Draw, right? Suppose we have one node over there, right? Another node, right? And the nice thing about these is that I can just point. So I'm using the dot next to point behind me like the previous, but that is because this is the front of the line, and this is the current back of the line, right? Front and then back, right? So the next person, so the next here, right, even though it's the same word, the context is slightly different. The next person in the line is the guy behind me. The next person in the line is the guy behind me. Right? Who's next? When things are being processed, we call next for the next person. So this would be temp, right? And the first thing we do is that we need to attach him, and then make him the back of the list. So we attach him by going back.next is equal to temp. And if it really bothers you, you can flip that around, the arrows around. Back.next is equal to temp, right? Who's going to be after back? And that's going to be temp. So then back is equal to temp, right? He's the new back of the line now. Okay, now yep, that was adding. Okay, so now when we need to remove the front of the line, so now basically if there's one thing in the line, but I'm not keeping track of the size, so how would I know? Well, if the front and the back are the same, then I know that basically it's got only one thing in the line, right? And this double equals, right? That's going to compare memory locations. So even if like front contains the same item as back, right? They both hold 5. This equals will still be false if they're two different nodes, right? Right? Because this node front will be a node with one memory location, back will be a node with another different memory location. So that will work out just fine because I'm comparing the memory locations, not what's inside the nodes. Okay, so E2 return is equal to front.item. Right, so this, again, this if statement only executes if the front and the back are the same node, not if they have the same item. And we know they're the same node if the two nodes we're comparing have the same memory location. If I wanted to compare what was inside them, I'd be doing dot equals and implementing a dot equals method. So if front is equal to back, that means that then I need to set front equals, so front is equal to null, back is equal to null to return. Otherwise, what do? I say that front is equal to front.next. Right? The front of the line is equal to the guy who's after the front of the line. And that's it. That's all I have to do. So let's go ahead and test this out in a separate video.